Fundamental Manufacturing Processes video series, examining the tools and techniques of precision manufacturing. This program is an introduction to casting. Casting is the solidification of molten metal that is poured into a mold or injected into a die having a cavity in the shape of the desired part. Casting is used in virtually every industry, since all metals can be cast. Even mill forms, such as bar and plate, are produced from cast metal. Casting is usually the quickest way to shape metal into a part. Because of this, casting is used both for prototyping as well as production of large quantity parts. Castings typically have an isotropic or uniform grain structure and properties, rather than the directional grain structure and properties of wrought metals. However, castings only approach the full or theoretical density of wrought metals. Surface porosity of castings can be eliminated by sealing with a resin or a metal. Internal porosity can be reduced by isostatic pressing, improving the casting's mechanical performance. Many casting processes utilize patterns. These are used to form the cavity of the mold into the shape to be cast. Reusable patterns are made of wood, plastic, or metal. Expendable patterns, so called because they're consumed in the mold-making process or by the poured metal during casting, are made of wax, plastic, or polystyrene foam, depending on the process. Patterns are oversized to accommodate metal shrinkage during solidification. They are given a taper or draft to ease release from the mold. Patterns may also include allowances for finish machining, location of the parting line, details for alignment of mold halves, and for metal transfer through the mold. Cores are needed to create the recesses, undercuts, and interior cavities that are often required for castings. Cores are produced from various materials using a variety of production methods. Casting processes can be grouped into three classifications: expendable mold, reusable pattern processes; expendable mold, expendable pattern processes; and permanent mold, no pattern processes. Which casting process to choose depends on part size, part configuration, part quantity, required tolerances, and the metal specified. Expendable mold, reusable pattern processes include sand mold casting, plaster mold casting, and ceramic mold casting. Although patterns can be reused many times, removing the casting from the mold necessitates breaking the mold. Thus, multiple parts require multiple molds. Sand mold casting, also called sand casting, is the most common casting process. It is applicable to a great variety of metals, and there is essentially no limit to the size of casting that can be made. Castings made in sand molds are not very precise, but production cost is generally lowest. Although the molds are expendable, the sand can usually be reconditioned for reuse. Sand molds, made in halves, are built by tightly packing the sand around the pattern in a flask. The upper mold half is called the cope, and the lower half the drag. The mold includes one or more risers, venting provisions, and a system for transferring the molten metal to the mold cavity. This system includes a pouring basin, sprue, runner system, and one or more gates. Once the sand has been compacted, the pattern and mold half are separated, and any loose sand is blown away. Cores, if required, are inserted into the mold. Once they are set, the mold is closed by aligning the cope and drag. The mold is then transferred to the pouring station. In casting, metal flows from the pouring basin through the sprue, runners, and gates to the mold cavity. Vent holes formed in the cope and drag, and often in the cores, permit trapped gases to escape. After filling the mold, the metal enters the riser or risers, which serve as reservoirs of excess metal to compensate for metal shrinkage during solidification. Once cooled, the casting is removed from the mold, and the metal in the runners and risers separated from the casting for remelting. Casting in sand molds is classified based on the type of sand used and variations in the mold-making process. These variations include casting in green sand molds, no-bake molds, and in shell molds. Green sand molds are made from a flexible mixture of silica sand, clay, and water. The sand is said to be green because of its moisture content. Although casting in green sand molds is a versatile process, thin sections are difficult to cast because they may be eroded by the molten metal, or the metal may cool and become solid before filling the sections. Also, part tolerances and machining allowances must be rather liberal. Very smooth finishes are not attainable, and certain metals can develop defects if cast in molds that contain moisture. No-bake sand molds, also known as air-set sand molds, are a mixture of sand and a resin binder. This mixture is packed around a pattern and sets quickly at room temperature. No-bake sand molds are extremely strong, erosion-resistant, and provide good dimensional accuracy and casting finish. Casting shakeout is excellent, and reclamation of the bonded sand is practical, although it is more costly than with green sand. Shell molds for sand casting are produced by heating a metal pattern and then rotating it upside down. This exposes the pattern to a mixture of fine silica sand and a resin binder, setting a layer of the mixture to the heated surface of the pattern. To complete the curing process, the coated pattern is covered and baked. Once cured, the hardened shells are removed from the pattern and serve as mold halves. Shell cores, which are produced similarly, are placed within the drag side of the mold. A bonding adhesive is then applied, and the cope side of the mold is aligned and secured, creating the finished shell mold. These shell molds can be produced quickly and store well for extended periods of time. Shell mold casting is a semi-precision process, permitting more intricate shapes, closer tolerances, and smoother finishes than using green or no-bake molds. The size of parts that can be cast in shell molds is limited, however, with most castings weighing less than 45 kilograms. Casting in plaster molds is a precision process for aluminum alloy, low-lead copper, and zinc alloy parts. Ferrous metals are unsuitable for plaster mold casting because the molds cannot withstand their high melting temperature. Plaster molds and cores are made largely of calcium sulfate or gypsum and water. Besides calcium sulfate, other mold ingredients may be used to improve moldability, reduce porosity, increase strength, and/or control contraction. The mixture, in slurry form, is poured over the pattern and allowed to set and harden. Once set, the mold is separated from the pattern and baked to remove the moisture. The molds may incorporate metal inserts called chills to speed solidification and enhance the strength of the casting in local regions. Plaster molds have low thermal conductivity, so castings take longer to solidify than in sand molds. Plaster mold castings are typically small, less than 45 kilograms by weight, usually much less. But cast shapes can be extremely complex and have very thin sections. Ceramic mold casting is also a precision process, and it is suitable for casting a wide range of ferrous and non-ferrous metals. The mold mixture, in slurry form, includes stable ceramic powders, binders, and gelling agents. It is poured over a pattern and sets in a few minutes to a strong, smooth, and rubbery gel. Once the mixture sets, the pattern is stripped from the mold, and the mold ignited to burn off the binder volatiles. The molds may be all ceramic, or to reduce cost, a composite made of a ceramic facing and an aggregate media known as chamotte. Parts weighing less than half a kilogram to several thousand kilograms can be cast to complex shapes. Expendable mold, expendable pattern processes include investment casting and evaporative foam casting. Investment casting is a precision process using primarily ceramic shell molds. Investment casting is also known as the lost wax process because wax, a principal pattern material, is consumed during the mold-making process. Consumable plastic patterns are also used. Investment casting patterns are made by injection molding. These patterns are assembled onto a wax post connected to a pouring cup. This pattern assembly, called a tree, usually incorporates complex runner systems to assist metal flow in the investment casting process. The shell mold is produced by dipping the pattern assembly several times in slurry and allowing it to dry between dips. The first slurry mixture consists of fine particles for smoothness. Subsequent dips are mixed with coarse particles to quickly build up thickness and provide strength. The wax is removed from the mold by melt-out in a furnace or autoclave. Then the mold is fired to remove moisture, cure the ceramic, and to preheat it for pouring. Both ferrous and non-ferrous metals can be investment cast. Once the metal has solidified, the mold is broken and the casting removed. The main advantage of investment casting is the complexity of shapes that can be cast to close tolerances, thin walls, and smooth finishes. Most investment cast parts weigh less than 4.5 kilograms. However, parts weighing over 100 kilograms are also made. Evaporative foam casting refers to the use of expendable polystyrene foam patterns in molds made of dry, unbonded sand. The process is also known as the lost foam or expanded polystyrene process. The pattern may be a single piece, or for complex shapes, an assembly of molded pieces. Patterns also can be clustered in groups to produce multiple parts at a time. The pattern is coated with a thin, high heat-resistant coating, usually silica. Once the coating is dry, the pattern is placed in a flask and surrounded by sand, which is vibrated for compaction against the pattern. Casting then proceeds with the poured metal evaporating the polystyrene foam and filling the cavity formed by the pattern. Evaporative foam casting has several advantages over conventional sand casting. These advantages include: a single flask replaces the cope and drag. Cores are not required. Polystyrene foam patterns are light in weight. There is no parting line, and the as-cast finish is smoother. Shapes with complex external and internal features can be cast in various irons: carbon and alloy steels, stainless steel, aluminum alloys, brass, and bronze. Instead of patterns, the shape to be cast in permanent mold no-pattern casting processes is machined in the mold material, usually metal or graphite. Mold cost is high, but the mold can be reused thousands of times. Permanent mold no-pattern casting processes include permanent mold casting, die casting, and centrifugal casting. Permanent mold casting is a semi-precision process, which because of the chilling effect of the molds, can provide superior mechanical properties. In addition, permanent mold casting can produce uniform shapes, close tolerances, and smooth finishes. Permanent molds are usually made of gray iron, carbon steel, hot work tool steels, or graphite. Permanent mold casting is suitable for casting many non-ferrous metals, including aluminum, copper, magnesium, lead, and zinc alloys. Some gray iron also can be cast. Permanent mold casting can be performed manually or automatically for large production runs. Permanent molds are typically preheated and maintained at required temperature for casting. This helps facilitate metal flow and reduces thermal damage to the mold. The parting line of the mold may be arranged vertically to ease removal of the casting. But since some metals are better cast in horizontal molds, tilting mechanisms can reposition the mold vertically after pouring. Once poured, the casting is cooled by auxiliary heating and cooling systems. Cores used for permanent mold casting can be metal operating in the mold or made of sand or plaster and placed in the mold before it is closed. If sand or plaster cores are used, the process is called semi-permanent mold casting. Inserts are also used to vent, cool, or heat selective sections of the casting, or to be cast in place for special features. Internal mold features are coated to prolong mold life, control metal solidification, and ease casting release. Coatings are classified as insulative or lubricating. Some coatings can provide both qualities. Die casting is a rapid, high-production process for simple or complex, often thin-wall, precision parts. Castings are usually small to moderate in size and cast of non-ferrous metals. The molten metal is forced under high pressure into the die of a horizontal, sometimes vertical die casting machine. One die half is attached to a fixed platen, the other die half to a movable platen. Die casting can produce a single part or multiple parts in a single metal charge, also called a shot. The two principal types of die casting machines are the hot chamber machine and the cold chamber machine. The hot chamber machine is used mainly for die casting zinc and other metals of low melting temperature. However, it is also used to die cast magnesium. The machine's shot end has a holding pot, which is a reservoir for the molten metal, and an injection system for transferring the metal to the die. The plunger end of the injection system and the lower portion of the transfer pipe are submerged in the molten metal. When the plunger rises, a charge of metal enters the pipe through a submerged port. When the plunger descends, it closes the port and drives the charge into the die, forming the part. The cold chamber machine is used primarily to die cast the higher temperature aluminum, magnesium, and copper alloys. In the cold chamber machine, the charge is supplied by ladle or feed system from an external furnace source. The plunger and metal transfer pipe are not submerged in the molten metal. The charge is poured ahead of the plunger face through a port in the pipe. As the plunger advances, it closes the port and drives the molten metal into the die. When the metal has solidified, the casting is released and the cycle repeats. Once released, the excess metal is trimmed from the casting. Centrifugal casting is the solidification of molten metal under the centrifugal force generated by a rapidly rotating permanent or expendable mold. The high force typically results in denser castings than are produced in static molds. Virtually all metals can be centrifugally cast. There are several types of centrifugal casting methods, including true centrifugal casting and semi-centrifugal casting. In true centrifugal casting, metal is poured into a mold rotated in the horizontal or vertical plane about its central axis. This method is used to produce large diameter tube, bimetal tube, and rolls of virtually any wall thickness and length. Outside diameter and length are controlled by the mold. Inside diameter is controlled by the amount of metal poured. In semi-centrifugal casting, the mold surrounds the casting and controls the shape being cast. The mold typically rotates horizontally, and the metal is usually poured through a central gate. Coring is required if the shape is hollow. Let's review the material contained in this videotape. Casting is the solidification of molten metal that is poured into a mold or injected into a die having a cavity in the shape of the desired part. Castings typically have an isotropic or uniform grain structure and properties rather than the directional grain structure and properties of wrought metals. Casting is usually the quickest way to shape metal into a part. Because of this, casting is used both for prototyping as well as production of large quantity parts. Many casting processes utilize patterns. These are used to form the cavity of the mold into the shape to be cast. Reusable patterns are made of wood, plastic, or metal. Expendable patterns, so called because they're consumed in the mold-making process or by the poured metal during casting, are made of wax, plastic, or polystyrene foam, depending on the process. Cores are needed to create the recesses, undercuts, and interior cavities that are often required for castings. Cores are produced from various materials using a variety of production methods. Casting processes can be grouped into three classifications: expendable mold, reusable pattern processes; expendable mold, expendable pattern processes; and permanent mold, no pattern processes. Expendable mold, reusable pattern processes include sand mold casting, plaster mold casting, and ceramic mold casting. Expendable mold, expendable pattern processes include investment casting and evaporative foam casting. Permanent mold, no pattern casting processes include permanent mold casting, die casting, and centrifugal casting.